In the last video, we talked about the truth functional form algorithm and how we can use that to assess what the truth functional form of a sentence is, and then identify whether a sentence might still be a tautology or if an argument is still valid, strictly in terms of the truth functional connectives like conjunction, negation, or the material conditional, or whether the validity actually depends on the quantifiers. In I might have misspoken in the last video lecture when I was talking about first order consequence as opposed to logical consequence. And for that unit, or for that particular problem that we were working on, that won't matter. But what I want to do now is get a little bit clearer on the difference between what are actually three different levels of validity, or three different types of assessments. So you'll see on page 273 in figure 10.2 that there are these three different levels of validity that depend on the type of information that you're looking at. And so I had hinted that there's some new information that we can now make use of, right? So in addition to predicates, we also have the connectives, but now we also have quantifiers. And so the fact that we can look at three different levels of information means that we're going to have these three different levels of validity. So you've seen a diagram like this before, right? Where we had tautologies, and then we had logical truths, and then we had Tarski world necessities, right? So there were statements that had to be true or necessarily true because of some constraints about the way that Tarski world works. We're going to put aside the question of Tarski's world and focus on a level that actually exists between logical truths and tautologies. And these are what we call first order validities. In addition to looking at this third level, I'm also going to use a new method called the replacement method to be able to check between the logical truth and the first order validities. But first, let me walk through the difference here. Okay, so on the very inside, we have tautologies like tet A or not tet A, right? If we do the truth functional form algorithm for this, what you end up getting is a sentence that looks like A or not A, right? So this is A or not A. And if you do a truth table for this, right, this will come up with as a classic tautology. Let's contrast this with the very outside claim. It's not the case that there exists an X such that X is left of X. If we apply the truth functional form algorithm to this, right, we would go on the inside of the negation, and then we would start underlining it right here, right? And so it looks like that sentence is equivalent to not A using the truth functional form algorithm. And that is neither a tautology. Yeah, it's not a tautology. Okay, so there's an in-between level that we can actually pay attention to, and here's what I have in mind. If we look at the meanings of the quantifiers and the predicate, what this sentence is saying is that it's not the case that there's an object. Let me erase this. It's not the case that there exists an object such that that object is left of that object, right? Itself. It's not the case that anything is left of itself. So that's true, right? If we look at the inside of the negation, the inside of the negation would say there exists something that is left of itself. But that's impossible, right? You can't be left of yourself. You're always in the same place as yourself. So the inside of the negation from here, we know has to always be false, right? And so if you take the negation of something that is always false, then that's always going to be true. So that's a logical truth. Now, what we might want to ask is how much of that logical truth depends on what the information that the quantifier is giving us, as opposed to the information of the predicates. So let's look at this in between sentence. For all x, cube x, then cube a. Here again, we've got a sentence that has both a quantifier and a and a predicate. Now, if we do the truth functional, or sorry, let me just write this out here. Cube a. So one of the things that we could do is ask, how much does it matter the fact that we're using the predicate cube? What happens if I didn't know what a cube was? What happens if instead um, cube was the word brill, right? So if I had instead the sentence for all x, brill x, then brill a. Well, what the sentence is saying is if, right, when we apply the truth functional form algorithm, we see that the conditional is the main connective here. So I can ask, okay, if everything in my domain satisfies the condition of being a brill, is that sufficient for the claim that given that I've got an object called A in my domain, right? So remember, if we're using a name, we're supposed to, or we get to assume that there exists some object in that domain. So there is an object called A. Does it follow that that thing is a brill based on this sufficient condition? And the answer is yes, right? If everything in the domain satisfies the condition of being brill, then A is a brill. So what we should notice here is that the predicate isn't really contributing any particular work to making sure that this sentence is always true. Rather, it's the quantifier, the universal quantifier is doing all the heavy lifting here for making sure that that sentence, the sentence right here, is always true, right? So even though we've got the predicate cube in there, the predicate cube isn't really contributing anything to the necessity of the claim being true. Okay, so that means in this level of first order validities, what matters are the quantifiers and the predicates don't really matter. So let's go back to this sentence, right? There exists, or it's not the case that there exists an x such that x is left of x. If we replace the predicate and we figure out a way to make that sentence come out false, then it can't just be the quantifier that's giving us the information that makes that sentence necessarily true. It has to be something about the quantifier and the particular meaning of the predicate. So, for example, let me use the predicate same size. So instead of having left of, I do, it's not the case that there exists an x such that, sorry, same size x. Right here, if I think about there exists an x such that x is the same size as x. Well, this sentence inside the scope of that negation is always going to be true, at least to the extent that we're talking about things that can have sizes. That means the negation, right? So if this is always true, that means this negation, so when we look outside of that, is always going to be false. So I've managed to come up with a counterexample by picking up on something about the meanings of the predicate, right? So if I switch out the left of with some other type of predicate, I realize that a lot of the necessity of this sentence, of the original one, depended on not just the quantifier and the the connective, the negation, but also the particular meaning of that predicate. So the replacement method, the idea behind the replacement method is to check to see what information that predicates are contributing and to see if that information matters to the necessity of the claim. So I'm going to clear all of this. So tautologies are defined as those sentences that are necessarily true, and they depend only on the connectives like what we've had, like negation, conjunction, right, disjunction, the conditional, and the biconditional. First order validities are all of these statements or all of these considerations plus, right, the nature of quantifiers and the existential, the universal and the existential quantifier. And logical truths are taking all of that, these two, plus the meanings of predicates. Meanings of predicates. With one small exception. The one predicate that we're going to include as part of the first order validities is identity. So if the only predicate that makes a difference is identity, then we still count that as a first order validity. But for all other predicates, like left of, same size, cube, being a tetrahedron, as soon as we care about those meanings of predicates and those meanings contribute important information that determines that something is necessarily true, that's when we have a logical truth. So what you'll notice is if you do this in Fitch and you use the goggles, you'll now have two different types of goggles that you can use. You can use the goggles for taut-con, or you can use the goggles for first order con. First order consequence will block out predicates, whereas taut-con blocked out entire sentences with the exception of the connectives. Right? So I recommend that you try that to see the difference there. The replacement method that we're talking about, so this is the replacement method. The idea here is that you use nonsense predicates to replace all of the ones that you have in the sentence and see whether the sentence still comes out as being necessarily true. So if I, for example, so replacement method, you do nonsense. Sorry, it's falling behind just a little bit. So we insert nonsense predicates. So if I replace left of with like brillig, so it's not the case that there exists an x such that x is brillig of x. If you don't know what brillig means, it's hard to know, it's impossible, in fact, to know whether this sentence is still necessarily true. And so that means that there's something important that is being contributed by left of for you to determine that that's necessarily a true sentence. So that's the idea behind the replacement method and how that can be used to distinguish between these three different particular levels of validity. In addition to looking at validity, the other thing that you'll notice above is that they have a table that they provide with the three different kinds of information that you're going to be paying attention to. So here they have what's called propositional logic. So here we talked about the concept of a tautology and what we just talked about, as well as a tautological consequence or tautological equivalence. Again, here What you care about is the truth functional connectives. The general notion that we've worked with up till now is over here on the right side, which had to do with logical truth, logical consequence, and logical equivalence. Here you get to, again, look at all the pieces of information, not just the connectives and not just the quantifiers, but also the meanings of any of the predicates that are being used. First order logic, where we're talking about first order validity, first order consequence, or first order equivalence, here, the only things that you're going to be looking at are the connectives plus the quantifiers, the universal quantifier. All right, so let me put this down. We're going to have the connectives from over here plus universal quantifier, the existential quantifier, as well as identity. So this is that third level that we were just talking about in that diagram. It's trying to pay attention to which information are we looking at, and in what ways is it contributing to the logic of either the sentence or the argument. Okay, so in the next little video lecture, I'll walk through some examples.